Okay, so we can start with problem number one. Okay, so what I always do, I give a student couple of minutes to work on problem by themselves. Okay, so try to read the problem, get some information, some data by reading the problem, and draw the situation. Okay, and write down those equations that you think help you to find the unknown value. Good. So you have 5 minutes, okay, and then after 5 minutes we can start working on the problem together, okay? Okay, so it is I'm gonna show you how I read the problem, and while I read the problem, how I gather the information that I need. Okay, so it's telling that a soccer player, okay, kicks the ball toward a goal that is 24 meters in front of her. Okay, so there is a person and there is a goalie, yes? And this goalie is how many meter? 24 meter away from the person. Good. The ball leaves her foot y equals 0. So it means that the ball is on the ground. Okay. So I just draw the ball. Okay. And the ball location, initial location of the ball. If my object of interest is ball, which is ball. Okay. So it's going to be the location of the ball, not the person. The ball and person at the beginning, they are in the same location. Good. The person is going to kick the ball. The person is stay. Good. The ball is going to move. We are analyzing the motion of the ball. Okay. So initial position of the ball is 0 meter. What does it mean? It means that we have a we need a coordinate system. Okay. So because this ball is gonna kick, okay, with this speed and with that angle, we will have a two-dimensional motion. For two-dimensional motion, we need a coordinate system. Okay, two-dimensional coordinate system, x and y. Where can I put the origin? Exactly, because the question is telling that y equals 0. Good. It's better to select my origin exactly where the ball is. Okay, so I use different color. So this is gonna be my x-axis. This will be my y-axis. Okay, so what does it mean? From here, I will get one more information. X0 is 0 meter as well. Yeah. X is gonna be 0 meter per meter as well. Okay, and it's telling that with the speed of 18 meter per second and with the angle of 31 degree. So it means that the ball is not gonna move horizontally. It's not gonna go like a free fall. Okay, it like a projectile. It does have 18 meter per second. But with what angle? Is the angle is theta is gonna be 31 degree. Okay, so the initial velocity is 18 meter per second, the magnitude. But because this is a two-dimensional motion like x and y, okay, we need to find that velocity's component in x-axis and y-axis. Okay, so what is the velocity component in x-axis? Vi cosine theta, yes? Vi cosine theta, Vi cosine theta, which is going to be 18 cosine 31. What is the VIY? VIY is going to be VI sine theta, which is going to be 18 sine 31. So, what is the rest of the problem? The regulation height of the soccer goal is 2.45. Let me just draw this. This height is 2.44 meter. Good. Ignore air resistance. Will she score? Okay, we just have this information. Initial position, initial ball, initial velocity in x-axis, initial velocity in y-axis, okay, and we know that the acceleration in x-axis is 0, yes? Acceleration in y-axis is negative g, or negative 9.8 meter per second square. The object moved with the constant velocity in the x-axis, object moved with the gravitational acceleration in the y-axis, okay. So what happened? How many scenarios is possible? Okay. Sometime I don't know. I say that, okay, if I didn't know this information, okay, so I kick the ball, it may doesn't reach, yes? Or it go into goalie, yes? Okay, good. Or it go and pass and reach here. Okay. So what information I have? 24, yes? Okay. So, and what other information have? 2.44. Good. So, and how these two number, how these two information can help me? What would be height? Yes. When the position of the particle is 24 meter. Okay. We would like to see that, that ball, reach to that 24 meter or not. Yes. Okay. Makes sense. Okay. So how can I find out? Let's say there was no goalie. Yes. Okay. There is nothing. I will draw this later. Okay. I would like to see what is the final position of this ball. No goalie. Good. I would like to see how far it goes. Okay. So it's gonna reach to the 24 or no? It's gonna pass the 24. Okay. If it's not gonna reach to the 24, perfect. Nothing. If it's more than 24, now I can say, okay, this ball can pass the 24. Let's see what is the Y location. If the Y location is below 2.44, it went to the goal, yes? If it's above the 2.44, nothing. Okay, so I would like to test the final position of the ball. Okay, so X final and Y final, okay? Where it land? How can I do that? XF is equal XI plus VIX T, yes? And YF equal YI plus VIY T plus 1 over 2 acceleration T squared. Good? Okay. So what is the XF? What is the final position? The ball lands somewhere, yes? The final position is gonna be, I don't know, okay, it's gonna be 0, yes? What is the initial position right now? 0. What is the initial velocity in y-axis? 18 sine 31 t plus 1 over 2 negative g t squared. Good? Okay. So how can I solve this? These help me to find the total time, yes? The ball was 0, now is 0. It's 0 as well, okay? The initial position, the final position. These help me to find the final time, okay? Total traveling time. Or if you don't want to use this, you remember the total traveling time, okay, you have the formula, yes? It is 2v0 sine, yes, theta over g. You remember that somewhere? We will get the same formula, okay? If I write this, okay, it is exactly the same formula. Total traveling time. But I don't want you to memorize the formula, okay? Make sense? So When I calculate this, okay, so it's gonna be how much? V0 is gonna be 18 sine 31 divided by 9.8. Because if I solve this, okay, it's gonna be exactly this one. Good. How much? What is the total traveling time? Do you have a calculator? Make sure that your degree, your mode is in degree. Yeah, 2 times 18 times sine 31 divided by 9.8. 1.89? 1.89. Okay. This is the total traveling time. How this time helped me? This time helped me to find the final position, to see that it's before 24 meter or after 24 meter. Yes. What is the final position here? XF is gonna be, what is the X for initial? 0 plus. What is the VIX? 18 cosine 31 time. What is the total traveling time? 1.89. Can you calculate this? 29.19, yes? Let me just, I can bring my calculator as well. How much did you get? 29.2. 29.2, yes? 29.2. What does it mean? The, yeah, the ball definitely, if there was no goalie, this ball with this velocity can go until 29, yes? Until here. This is 29. But my goalie right now is here, yes? Okay. Definitely is not this scenario, yes? It is this scenario, okay? But we don't know what is the Y position, yes? We know that definitely past the goalie. Definitely. Okay, what I can do, I can say I would be able to find the Y position when the ball is here, when it XF is 24, yes? I can find again, this we were not solving the problem. We were trying to test to see that the ball will reach to the goalie or pass the goalie. Now we tested that definitely will pass the goalie. I can say what would be the Y position of the ball when the X position is 24. Make sense? Okay. So what I do, I just erase this. Again, I write the formula one more time. YF equal YI plus VIYT plus 1 over 2 AYT squared, and XF equal XI VIXT. Good? So I would like to see what is the Y value position, final position, when the X final is exactly where the goal is. Yes? So I put this 24. What is the xi? 0. What is the vix? 18. Cosine 31. Good. So what is the time here? It's going to be 24 divided by 18 cosine 31. This helped me to find the time. When I find the time, I can plug to the first equation. I can find the y value, the y location. So what is this value? 1.6. 1.6 second. Okay. So, and if I want to see what is the y value when the time is 1.6, okay, what I do, I just plug it here. It's going to be equal, what is the y0? 0. Plus, what is the VIY? 18 sine 31 multiplied by, what is the time? 1.6 plus 1 over 2. What is the acceleration? negative 9.8. Again, what is the time? 1.6 power of 2. Yes? So, okay. How much did you get? 2.5?
But my X value that I got was 1.1. So 1.6.
Oh,
For the cosine.
you got the different time? Okay, let me just redo this. Okay, so let's do the time first. 24 divided by 18 cosine 31. This is going to be 1.55. Okay, let's just put exactly 1.55. Okay, for now. 1.55. Okay, so I put 1.55 and then 1.55. Okay, so let's say what happened. So 18 sine of 31 multiplied by 1.55. So this part is gonna be 14.37. How about the other part? Negative 4.9 times 1.55 power of 2, yes? It's gonna be negative 11.77. Good? So again, what I do, I just add these two plus it's gonna be 2.59. Good? So what does it mean? What is the y location here? When the ball is at x, okay, the y location is gonna be above because this is 2.44, yes? What we get for the y value, it is 2.59, yes? Definitely is too high, okay? Makes sense? Did you get the same thing in the class?
We didn't actually do the.
We didn't finish it.
Okay, you didn't.
We just.
He got it.
Okay.
Set the problem out.
Yeah.
You just have to set the problem out to solve.
I couldn't hear.
Set the problem out.
Set the problem, okay, so. What is, did you check the?
Yeah. She got 2.55.
5.5, okay, so yeah. It's not gonna, yeah. Okay, so any question? Okay, again, she might not tested this. Okay, I tested to see what is the final. If there is no goalie, okay, where this ball goes. Okay, so it's gonna hit. It's gonna pass the goalie or not. Okay, let's say yes, it is passed. So if it is passed, okay, then find out. Okay, what is the YF? Okay, so at X final when X final is 24. Okay, let's do problem number. Okay, problem number 2, 3, which one? Can give this to her to write. If you want, we can go one by one. Okay, we can do. Okay, let's do number 2. Problem number 2. Thank you. Okay, this is problem number 2 again. 5 minutes. Read the problem, draw the situation, gather some data, look at the equation, see how far you can go. Let's hit the record. Okay, so this is again example of a two-dimensional motion. Good. And again, I will read the problem. And it's telling a bicycle ride in a hilly countryside. A cyclist approached the bottom of the uphill. Okay, let's say bottom of uphill. Okay, good. So, and climb at 10 meters per second. Okay. And it's telling that this is the initial velocity parallel to the incline. Let's say this is the incline. Yes. Good. And this velocity is parallel to the incline, which is 10 meters per second. And what is the angle? Okay, so it's telling the cyclist decide to coast up the hill as far as he can before turning the pedal again. It means that it should go until about to stop, yes? Then he decide to pedal again. Okay, so, and what is the degree? Theta is, if I could draw a little better. So, let's say this, yes. And it is 9 degree, theta is 9 degree, and the velocity of the bike is 10 meter per second. And it goes, let's say this is at the bicycle, okay, and it goes somewhere here, okay. It may reach to the top, okay, it may just in the middle, okay. So, but we know that the velocity at this point become almost 0, okay. So, how long it takes before he has to starting, pedaling again. Okay, so, but again, let me just say like this, not 0. So if we assume that this is an example of, two-dimensional motion, again, we have Vix, which is going to be 10 cosine 9 degrees. Okay, Viy is going to be 10 sine 9 degree. It reached to some point, okay, so we know that in x-axis, the velocity is constant, doesn't change. So this velocity again is going to be what? 10 cosine 9 degree, but the velocity in y-axis, okay, is going to be what? 0, okay? The velocity in y-axis is 0, okay? Is the time that he decide to just start pedaling. Make sense? Because it's moving, it's gonna move to the right, okay, but it's not gonna move upward. Good. So how long does it take? What formula we can use? V final y, V initial y, yes. Ay equal t. And we have other 3 formula as well, okay. Yf yi plus viy plus 1/2 ayt squared, and then v final y squared, v initial y squared, 2ay, yf minus yi. Okay. And then we can write the x component as well. Okay. We just write the same thing, but we need to just make the acceleration 0. So the xf is going to be what? Xf is going to be xi plus a vix time t. Yes. This is the 4 formula that we have to just find the unknown value. So because it's telling that how long will it take him before he has to start pedaling? What does it mean? Can we use this?
Time for initial velocity
We have initial velocity, the final velocity in y-axis. We have acceleration in y-axis, which is negative 9.8 meter per second squared. There you go. We can find the time. Okay. So what we do, we just say v final 0, v initial is 10 sine 9 degree plus, what is the acceleration? Negative 9.8 multiplied by time. So calculate the time. Time is going to be negative 10 sine 9 degree over negative 9.8, or 10 sine 9 degree over 9.8. So let's just do this calculation. 10 sine of 9 divided by 9.8. How much time? 0.16 second. Okay. So how far will it take? So how high it goes, yes? So we need to find the x component, yes? And we need to find the y component. If we have x, we have y, we can use the Pythagorean formula, yes? Okay, and find the distance. How far it goes. Okay, it's telling that what is the d? D is gonna be x squared plus y squared, yes? What is the x? This x is x final. What is the y? Y is y final. Okay, and we have y final formula here. Y final and x final. So I rewrite the formula one more time. Let's talk about the xf. Xf is going to be xi plus vix multiplied by time. We say that this is the origin, yes? 0, 0. Xi is 0. Vix is going to be 10 cosine 9 degree multiplied. What is the time? 1.16. Good. Okay. How much it is then? Okay. 10 cosine 9 multiplied by 0.16 is going to be 1 point, xf is going to be 1.58 meter. What is the yf? Yf is going to be yi plus viyt plus 1 over 2 ayt squared. So yi is 0 plus, what is the vii? 10 sine 9 degree. What is the time again? 0.16 plus 1 over 2 negative 9.8 0.16 power of 2. Okay, let's do this. 10, not tangent. AY sine of 9. Okay, minus 4.9 multiplied by 0.16 power of 2, yes? Am I right? 10 sine 9. Okay, I didn't multiply this, okay, so I have to rewrite everything. So 0.16 minus 4.9 times 1.16 power of 2 delete. Yes? Oh? Okay, we need to erase that. Good.
Want to delete your other one.
Good. So it's gonna be how much? YF is gonna be 1.2. So we have XF, we have YF, yes? We just plug 2 because it's telling that, what is the D distance, yes? You just move XF to the right, YF to the top. Good? So D is gonna be 1.56 power of 2 plus 0.12 power of what is that value? 1.56 power of 2 plus 0.12 power of 2. Second, squared second answer 1.56.
Yeah, but I don't think
That's
she
not-
got-
This is her, like solving it. We do a different way in class. So we use the ramp.
Oh yeah, I use the ramp. Okay, so AX is AX is
I don't know if she shows it. Yeah. Because we tilt it, the y-axis, that way we can just use the x-axis to find it.
okay. Skip that. Okay, so I will show you. Okay, what I missed. Okay, so you know this is going up. Yes, it's gonna reach to one point here. Okay. Okay. So let's say the object is in the middle. Good. So the only gravity that is experiencing, yes, is the force of gravity. Okay. So, and this force of gravity is going to be G. Good. So, and we just use the coordinate system. We just say this is the x-axis. You can say this is the x-axis, yes, or this is the y-axis, okay. Or you can say this is the x-axis, this is the y-axis, okay. So which one do you think is better? This one? Okay, why? Because you just need to find one component value. Okay, you just find you try to just break down the acceleration component, okay? And then you don't need to find the y value because the y value is always 0 here, yes? But this one, okay, if you use the x and y coordinate, not only you have to find the x value, you need to find the y value as well, okay? So I will erase this, yes? And then this is gonna be, okay. So what I do, I draw this x component, yes, and y component. Okay, this is a 9 degree, yes? And the velocity was how much? 10 meter per second. Because this is a velocity, yes, in x-axis. What is the initial velocity in x-axis? 10 meter per second. What is the velocity, initial velocity in y-axis? 0 meter per second. What is the acceleration in x-axis? I don't know. What is the acceleration in y-axis? I don't know. Okay, good. Because acceleration is here in this direction. This is 9. This will be 9. Okay. So I can use, this component. This is going to be g cosine 9 degree, yes? And this will be g sine 9 degree, yes? Okay. What is the ax then? Negative g sine 9 degree, yes? What is the ay? Negative g cosine 9 degree. Okay, good. So what is the xf position? We don't know. What is the yf position? Is it still 0? Yes? Okay. So what else we have? Because we have in 2 dimension we have acceleration. Okay, it means that we need to write those 3 equation, okay, with the acceleration for both. Xf equal xi plus bi xt plus 1 over 2 axt squared, and then yf equal yi plus bi y t plus 1 over 2 ayt squared. Good. And then what is the other formula? V final x squared v final initial x squared 2ax x final minus xi, and v final y v initial y squared 2ay yf minus yi. Good. And what is the last one? Vfx vix plus axt v final y equal v initial y plus ay t. Okay, so what is the v final x here?
Would have to be 0.
Would have to be 0, okay, because it's come to a stop, okay. What is the v final in the y-axis? Again, is still 0. Good. So what the question was asking, how long does it take to go up? Yes. Which formula I can use? I have 6 formula. Which one I think I can use?
The bottom left one.
There you go. Bottom, this one. Yes. Okay. So I just write it here because I have v final y. I have v initial I. Okay. So, and I have acceleration in x-axis, and I can find a final. So v final x, v initial x plus axt. 0, 10 plus, what is the acceleration?
Negative.
-9 sine of 9, yes, t. So what would be the t?
9.8. That's we're using G.
What I said.
Or
No, I mean g, yes. 9, yeah, g. It is a 9.8, okay. So t is gonna be 10 divided by 9.8 sine 9, yes? So what we have? 10 divided by 9.8 multiplied by sine of, did you get the same thing?
Yep.
6.5. Good. When you have time, okay, which one you can use to find the final position? This one. X final is going to be 0. What is the x initial? 10 times 6.5 plus 1 over 2. What is the acceleration again in x-axis? -9 sine 9, again, -9.8 sine 9 degree time 6.52. What did you get?
I'd have to do that.
Okay, so we can calculate that.
Let's say I got about 30.